Hello and welcome once again. This is going to be very wonderful because each question will help us to answer many likely questions on this. So please let's attend to all these very quickly. So if the kinetic energy of an electron is 100 electron volts, what is the wavelength of the Broglie wave associated with? Look at the constants given to you. So we are going to use this. So normally, the Broglie's wavelength is given as the Planck's constant over the momentum. And momentum is given, this is the formula, 2m, 2em, or 2me, 2 times mass times kinetic energy, or em. That's just like this one. So now, let's get the value of this before we can now use this Planck's constant given here to solve this thing. So this is equal to square root of 2 times mass of an electron 9.1 times 10 raised to power minus 31 times the energy is given as 100 electron volts, electron charge. So this one is 1.6 times 10 raised to power minus 19. So you have 100 times this value. So we say 100 times 1.6 times 10 raised to power minus 19. Now if you want this times 100 times 1.6, you find it. This question was given to me by one of the students. I don't know, on WhatsApp, so I don't know the place. One of subscribers, let me put it like that. So I have decided to solve because it's going to help other students. So if you use your calculator to multiply this with the powers, this and find the square root, to give you 5.4 times 10 raised to power minus 24 meters per second. So now we are going to get the we are going to get the wavelength now. H is what? 6.6 times 10 raised to power minus 34 divided by the momentum. Momentum generally, is mass times velocity. So kilogram meters per second, something like this. Now, but this is not what we are talking about. All right. So we have 6.6 times 10 raised to power minus 34 over 5.4 times 10 raised to power minus 24. If this divides this, it will give you 1.22. 24 minus 34 plus plus 24 will give you times 10 raised to power minus 10. So this wavelength is in meters. So this is the answer to this very question. So let's solve the number 2 question. Let's solve this very one. So whenever you are given something like this, please don't forget that energy is Planck's constant times frequency. We have done this thing a number of times, right? I think in one of the questions I solved, it is also part of it. So you can replace this frequency by this. So you can still cross multiply over the energy. So anyone is in this form or in this form, anyone you are given, you can always solve it. All right. So and if energy level is given to you, excitation upper minus lower. All right, so please go and study it more. We don't have much time. Permit us to clean the board now and solve the next question. We continued from where we stopped in our last video. So the half-life of a radioactive material is 15 hours. If at some instance the sample has a mass of 512 grams, calculate the time it will take 7/8 of the sample to decay. So let's solve this question. Half-life. I told you last time that the first half is 1/2 raised to power 1, second half 1/2 raised to power 2, third half 1/2 raised to power 3, and it continues. This is 1/2, 1/4, 1/8, something like this. So if we are going to look at something like this to use it, now watch, let me take it a bit slowly. 15 hours. This 7/8 of the sample to decay means amount remaining, amount left after this is 1/8. 7/8. Then amount left is 1/8. So let's use this 1/8 to get the value 1/8. This 1/8 means in half, in form of half-life, half. This means 1/2 raised to power 3. So here, this one gives us 3 half-lives. Because this first, second, third. See it? So it's 3 half-lives, as I showed you here. So 3 half-lives, 15 hours. So there's going to be 15 hours plus 15 hours plus 15 hours. That is 45 hours solved. Or the other way around, this is another method of solving it. In every 15 hours, see, original mass is 512, so every 15 hours it is going to come down. But first of all, we are going to use this remainder, another method of solving it. So the remainder is 1 over 8. 1 over 8 of 512 will give you 8 in 51 6. Remainder what is 8 51 6 64 grams. Remainder 3 32, so 64 grams. So this 64 grams is what we are going to use to work with. So let's break it down until we get 64 grams. So in the first place, it is 512, 15 hours. 15 hours will now give us 512 divided by 2. 2 in 5, 2 in 11 will give us 5 in 12, 6 grams. So we'll bring this 256 here. 256 grams, another 15 hours. Now to divide this, because it's half, we are going to be dividing into half. 2 divide 2, 1. Divide 5, 2. Divide 16, 8. So another 1 to 8 now. 1 to 8. We bring it forward. Another 15 hours. 2 divide 12, 6. Then 2 divide 8, 4. So you see that we have gotten this 64 grams. So how many hours? 15 plus 15. 15 plus 15 plus 15. We still give what? 45 hours. So we have used two methods to solve this same question. So let's look at this very one, number 8. Because it's a continuation of the other video. We just did 1 to 5. So now we decided to complete it 8. Then we are doing more. So if you have not seen the last video, please go and check them. So let's look at this one. The distance between the fixed points of a mercury in glass thermometer. Mercury in glass. Now let me tell you something before I continue. Something has told me to just say it. See, why is mercury better than water as a thermometric substance? Number one, the main reason they will always give you past questions. Water wets glass. That is why it cannot. Water wets glass, but mercury does not. Now this you can discuss this under force of cohesion and adhesion. My mind just told me to do this, so I decided as I saw mercury in glass, I decided to do this now. Freestyle. Now, what is force of cohesion and what is force of adhesion? Adhesion between the force that exists between two different molecules. Two different molecules that can exist between two different molecules. But cohesion, same molecule. Now, if anyone is higher than the other, it exists. Let me explain it. The force of adhesion between water and glass is high. So water can adhere. You know, sometimes they say adhesive. Sometimes used to hold two things together. Adhesive. So water has higher tendency to adhere with the glass. So that is why if it adheres with the glass, it wets the glass. That's why if you are driving and it's raining, sometimes the inner part of it gets wet. You have to unless you use the dryer. So now that is what you have here like this. So force of adhesion between the water and glass is high. That is why water wets glass. So it can easily adhere with the glass. Now mercury, the force of cohesion between the molecules of that mercury will just stay like this on its own. When you put it on glass, it cannot just stay on its own. As you may have oil in water, so they will just stay on their own. So mercury does not wet glass, and that is why mercury is a good thermometric substance, because it can rise and fall. You can read it easily than water in glass thermometer. So the force of mercury does not wet glass because the force of cohesion in mercury is high. Water wets glass because the force of adhesion between the water and the glass is high. So that is the main reason why water wets glass, while mercury does not wet glass. So we have just done this as an additional information. As I told you, when we try to solve one question, we may be able to answer many other questions. God is going to help you to make good score. So let's look at this one. We are going to look at something like this. Is 30 cm. Determine the temperature when the mercury level is 10.5 cm above the lower fixed point. Above the lower fixed point. So if you have something like this, I want every one of you to pass. That's why I'm trying to do this today. So and upload and get you like completely committed to your studies. Alright. So we now have this now the different distance between this and this. The distance between this and this. Are you there with me? The distance between the upper and lower fixed point is 30 cm. So we have this place is 30. This is the lower one, 0. So 30 minus 0 is 30. But if this is another question, this one will have another value. But since it's 30 cm, the distance it's already given to you. Maybe you have 70 at upper fixed point and 20 at lower fixed point. Say 70 minus 20. You have 70 here, 20. So it will give you 50. But this one is already solved. It's 30. So this place means this place is what? 0. This is upper fixed point. The temperature of boiling water, upper fixed point. Temperature of steam, upper fixed point. Temperature of steam. So that's why I put it 100 degrees Celsius. Lower fixed point. The temperature of ice. Temperature of what? Ice. Lower fixed point. Now, this is the place we are going to determine. It says when the level is 10.5 cm. 10.5 cm here. What is this temperature? This is what we are looking for. Now there are two ways of doing this. Watch. So you can say x minus this minus this over this minus this over 100 minus 0 is equal to this 10.5 minus 0 over what? 30 minus 0. So now this minus 0 means x over 100 equal to 10.5 over 30. If we cross multiply this to have 30x is equal to 100 times 10.5. So now x finally is 100 times 10.5 all over 30. As I told you, you can remove this point here. You can remove this point here by making it times 10. So 1 over 105. So we don't use calculator here. So 0 cancels 0, 0 cancels 0. 3 divided 10 is 3. Remember 1. 3 divided 15, 5. So the temperature is 35 degrees Celsius. So that is for this one. Alright, let's clean the board and get some new questions now. Okay, let's continue with the questions. Look at that question now. So we have, this is an alternating current. 30 ohms, 40 ohms. This one is resistor, this one is capacitor. But now, this thing is given to you in final value. Capacitive reactance. Let me give you the formula, then I will come to something like this to show you something. So now, says in the AC circuit above, the current value is, what is the current value? So now, normally, the current value for an alternating current is the potential difference over Z. This Z is impedance, opposition to free flow of current, maximum opposition. The impedance, just like you have in Ohm's law, then you have I equal to V over R. This one is from Ohm's law. This one is for alternating current. So take note of this. They are similar. Resistance prevents. Impedance, impede, the same thing. But this one is an alternating current. Now, formula for impedance is, for this RL circuit, is XC plus RC circuit rather, plus what? R. This one is square. This one is square. Right? But if it is RLC circuit, which is something like this. This is resistor, inductor, capacitor. RLC circuit. You have the impedance is square root of XC square minus XL square plus R square. Now, what is this XC? This is capacitive reactance. Capacitive reactance is equal to 1 over 2 pi FC. Capacitive reactance 1 over 2 pi FC. For this, because this capacitor is in series. Capacitors in series, as we all know, is always like C1, C2, C3. 1 over C equal to 1 over C1, 1 over C2, 1 over C3. But when they are parallel like this, you add C1, C2, C3, just C1 plus C2 plus C3, something like this. Hope you can get that. So now, but this one, there it is in series with this, so 1 over 2 pi Fc. But if it now inductive reactance, I'm doing this in case you are asked to find the capacitive reactance. If you are asked to find capacitive reactance, is 1 over 2 pi Fc. But if that is the case, what they are going to give you here, the unit you are going to have here will be something like 2 microfarad, 2.0 microfarad. This means 2 times 10 raised to the power minus 6 farad. If it is like 2 millifarad, 2 millifarad, this means 2 times 10 raised to the power minus 3 farads. This is it, see it, milli, 10 raised to the power minus 3, micro, like you, 10 raised to the power minus 6. So you now convert it and continue solving it. It's not difficult. Use this formula for capacitive reactance. Then inductive reactance is 2 pi FL. This one is not 1 over. Capacity SC is 1 over. XL is not 1 over. Take note of that. Alright, I think you have gotten something now, and it's now in full. So let's now solve this. So what is our, now this thing is already solved because it is in ohms. So it's not given to us in microfarad, neither in millifarad. So it is in ohms, which means this is the capacitive reactance. So it's already there. So we now say square root of 40 raised to power 2 plus 30 raised to power 2. Alright, so 40 raised to power 2 is 1600. 30 raised to power 2 is 900. Now this one will give you, this and this will give you 2500. So square root of 2500 is 50. So if the impedance is now 50, so we can finish it. Now current is equal to the potential difference over what? Impedance. See it, V 200. So we say 200 over Z, which is what? 50. This cancels this. 5 in 20, 4.00 amperes. This is the correct answer. So we have gotten it now. So I hope this one is very clear. Simple alternating current. Go and check more about it. It's not difficult at all. So I want you to also assignments. Write the formula of the following: VRMS and IRMS. Root mean square. Write their formula. And what are they about? VRMS, IRMS. So alright, thank you very much. Find out and apply. And what is the peak voltage? What is the peak current and peak voltage? Find out. Peak current like this and peak voltage like this. Some things like this. Find out. And the graphs that are involved in alternating currents. Alright, so they are important. Alright, so now we'll go to this one. The primary coil of a transformer has N turns and is connected to a 120 volt AC power line. If the secondary coil has 100 turns, in transformer, what you always talk about is most of the time you can use number of turns in primary over number of turns in secondary, voltage of primary over voltage of secondary. Alright, so now it can be any of this, NP over NS over NP, VS over VP, any one at all. So let's continue like this. Okay, thank you very much for doing that. Alright, so now this is a transformer. If this is source of power that enters this transformer, this is where you have primary coil. This is where you have secondary coil. Comes out like this. So if the number of turns in primary is greater than number of turns in secondary, this one is more than this. This is small, which means it's a step down. It's a step down. It's down, it's low. But if the number of turns in primary is less than number of turns in secondary, which means number of turns in secondary is bigger. Let me put it like this to avoid confusion. Number of turns in secondary is now greater than number of turns in primary. Is what? A step up transformer. This one is small, this one is big. So it has been stepped up from small number of coils to big, larger number of coils. So know this is very, very important. Alright, so now we can solve this question. Now look at it as it enters. The primary coil of a transformer has N turns. So number of turns in primary is just N. And it connected to a 120 volts AC. So voltage of primary is 120 volts. Now, if the secondary coil has 1000 turns, number of turns in secondary is 1000. So, and the terminal voltage of 1200 volts. Voltage of secondary is 1200. Now, what is the value of N? We can fix it in this formula. So we have NP is N over NS 1000. Where is NS? 1000. Okay, equal to VP 120 over VS 1200. You can cancel this like this. So, but let's do it like this. So N times 1200 equal to 120 times 1000. So N equal to, let's do it here. So N equal to 120 times 1000 all over 1200. This cancels this. 12 cancels 120, 10. So N equal to what? 100. 10 times 10 is 100 what? Tons. This is the answer. 100 tons. So this one has 1000 tons. This one has 100 tons. In relationship, you can see 120 volts, 1200 volts, just like 10 times 10. So this one will be like in that form too. This one divided by 10. So this one divided by 10 will still give you the same thing. So this is very, very correct, confirmed and correct. So now we can move to this very question, number 11. All right. Let's do it quickly. Here we are using this space to manage. We are managing our space. Okay. So see number 11 question. The joule is equivalent to, this joule is unit of work done or energy. Work done. You know, work done is force times what? Distance. So we are doing this. Is just like fundamental units. This one is derived unit. We are deriving it from the fundamental units. The fundamental units are those independent units which you know as what? Mass, length, and time, which is kilogram, meters, seconds, amount of substance, and the rest of them. But these are the basic ones we always use in this. Then the derived units are all those other units that are not of the fundamental units. They are obtained from the fundamental units. Derived. So this one is one of the derived units. Let's derive the unit of joules here. So now, force work done is force times distance. The joule is the same thing as work done and energy. Now force times distance. Force is mass times acceleration. So mg, this distance you can still call it s or h, any one. So mass, the unit of mass is what? Mass is kilograms. This is acceleration. Acceleration, let's use A is equal to change in velocity over time. Change in velocity. So if we say, okay, we can even continue to go to derive this one. Now velocity is distance, displacement over time. I hope I'm not taking much time on this, because so many of you already know it. Displacement over time. Displacement is distance traveled in a specific direction. So it is distance, meters, time is seconds. So speed, velocity is the unit of velocity, meters per second. So we are divide this one. So acceleration, this change in velocity, this one, this minus this is still this unit. So acceleration is meters per second over second. So this s coming up here will become ms minus 2. So we have derived acceleration now. Meters per second square. To bring this here, so it's g. We are going to bring this here. So we have times this g, meters per second square. Then this distance is also in what? Meters. So we have kilograms, meters times meters. Meters square per second square. So this is the which one? Kilogram meter square per second. So okay, this is the answer now. All right. Let's solve this question. Uniform meter rule is balanced on a uniform meter rule. Let me say something about this. So this is a uniform meter rule is 1 meter. That's 100 cm. So now this is the center. This is where the weight is. See the weight. So from here to here is 50 cm. Half of 100 cm. 50 cm. It's 1 meter, that is 100 cm. This is 0 mark. So it's balanced on a fulcrum. So see, let's look at our at 35 cm. So from here to here is 35 cm. So I have to replace here 35 cm from here to here, right? Now, and it says by suspending a mass of 120 grams at 10 cm mark. So from here to here is 10 cm. So this is the mass here. Put that mass here. Let me use this like this. 120 grams. So if I have here 10 cm, from here to here to here is 35. So it's remaining how many now? How many? 25 cm. So that from here to here is 35. Now, here to here is 50. This place is 35. This place will be remaining 15 cm. So 35 plus 15 is still 50. So we can specify here 15 cm. We have finished this question like this. So this side, this is how your clock moves. This is clockwise. This is the opposite, anti-clockwise. So principle of moment. The clockwise, anti-clockwise equal to clockwise. So the anti-clockwise moment equal to what? Clockwise moment. Or clockwise moment equal to anti-clockwise moment. So you can say moment of force. Moment is force times what? Distance. So this times this is equal to this times this. So we'll take it like this. Oh yeah. W times 15 is 15 W equal to 120 times 25. So the weight now is 120 times 25 all divided by what? 15. Let's break it down. Alright, 5 divide 25, 5. 5 divide 15 is 3. 3 divide 1. 3 divide 12. 4 divide 0. 40 times 5 is what? 200 grams. So this meter weighs 200 grams. So we call it a wrap here. God bless you. Surely make good scores. Mr. Primus says, good luck to you.